John Dalton was a modest, intelligent man, a deep thinker, and in his societal surroundings. He acted gracefully, as his head was teeming with radical ideas. Scientists then had just discovered something important about how elements combine to form compounds. And when they merge in the same quantities. So Dalton knew that the common salt, which is sodium chloride, always consists of one molecule of sodium and one molecule of chloride. Whether the salt comes from India or Siberia, it is formed from the same proportion of atoms in both cases. Dalton confirmed that for this to happen, each element must be composed of certain unique masses, when he called the unique molecules the name of atoms. This was a brilliant discovery, leaving all common beliefs and suggesting that everything but the entire universe consists of simple infinitesimal particles. Dalton worked hard to research this idea from his theory of matter. Dalton was describing to us something revolutionary and exciting. As he reached the foundations of the atomic theory, foreshadowing research that was not proven until a later century later. Dalton assumed that there are as many types of atoms as the elements themselves, and just as each element is different from the other, the atom of each element is different in weight and has a unique weight in it. Each element has its own confined atomic weight, atomic mass, whether it is solid or liquid or an invader. If we come with 3 balloons of equal size and fill each of them with a different gas, and since they are almost the same size, then each balloon must have the same number of atoms according to Dalton's theory. Different atoms have different atomic mass weights, so these balloons should have a measure of weight different. And if we fill the first balloon with helium gas and release it, it will rise in the atmosphere quickly because the weight of helium atoms is light compared to the weight of the air. So Dalton was on the right track. Different atoms of different elements have different weights, masses. Based on this theory and working completely alone, Dalton made one of the first attempts to impose a specific system on the random world of chemical elements, which is the Dalton group or the Dalton matrix of the elements, in which he arranged the elements in order according to weight, starting with hydrogen number 1, and then descending to see that oxygen number 7, and all the way to mercury, which occupies the rank 67. Dalton did not write all the papers correctly, but he was able to achieve a giant leap for the theory, based on his work only from his imagination.
Second, substance particles, atoms, and their movement.
At this exciting time, the science of physics was able to provide an astonishing conception of what is happening at that time to the particles of matter, i.e. the particles that the scientific community imagined at the time that any substance must be composed of, or the infinitesimal parts of matter or its particles that consist of it. The perception is based on the fact that the hidden movement of the particles or particles that make up matter never stops under any circumstances. Why, then, do we not see all these movements? The tiny particles that make up the body move, but the body itself remains stationary. How does that happen? Here's an explanation. Have you ever seen a flock of flying fringes? The swarm of fringes here appears, on quiet, awakening days, as if it is suspended in the air, while the movement is abundant within the swarm itself, and we find that within the cloud of the swarm, thousands of fringes move to the right and thousands of others move to the left, while the entire swarm remains static and conservative in its outward appearance. The hidden movements of atoms and molecules bear the same chaotic, random character in particular. When some molecules leave the space they occupy, other molecules replace them immediately. Since the new entering particles do not differ from the leaving particles, the body remains as it is without change. The random chaotic movement of fine particles cannot change the properties of the visible object. But this astonishing notion needed proof.
The great progress in the manufacture of lenses in that period made it possible to provide assistance to these early pioneers of brilliant scientists in the science of physics, and give them opportunities to present proofs of the validity of their ideas. Towards the academics who are always skeptical and confined within the science they were taught, progress in the manufacture of lenses made it possible for a distinguished British scientist, Robert Brown. To provide proof of the validity of ideas and assumptions regarding the properties of the supposed matter particles. He was watching under the microscope the internal structure of the plant, and he noticed that the floating particles in the plant sap were moving. And the scientist wondered about the forces that compel these fine particles on the move. Couldn't those tiny particles be living creatures? Therefore, he resorted to observing the non-living, soft clay particles wetted with water, and saw with his own eyes that these fine non-living particles did not live in their place, as they were moving in a continuous random movement. The smaller the number of these particles in the substance, its density, the faster its movement. The Brownian motion of fine particles of matter is the very thermal motion. Thermal motion is a general characteristic of large and small particles. Independent molecules and atoms also, this amazing discovery confirming the idea that bodies consist of moving particles, and that the speed of movement of these particles expresses the heat of these bodies was an absolute confirmation that heat is movement and movement is heat. Both are images of the other. Exactly as Rumford said when he was observing the movement while piercing cannon tubes.
How many atoms are in a unit volume, Avogadro's number?
Until 1869, there was not much knowledge about atoms. They were visualized as small, solid spherical bodies with a size of about 10 to 8, and a weight ranging between, October 22, 24, grams. Each body was attributed to its atomic weight, which is a number indicating its weight, its mass, and how many times is it heavier than a hydrogen atom, 4 times for helium or 16 times for oxygen. Or using the language of chemistry, 1 gram of any substance contains the same number of atoms, and this number equals, N equals 6.022 x 1023, and is called the Avogadro number relative to the world Italian Avogadro. Avogadro's number is the number of molecules in 22.4 liters of gas under constant temperature and pressure. And it is linked to the L number, N equals Lx 22.400 cm3, where the Loschmidt number is the number of molecules in 1 cubic centimeter of a gas, under standard pressure. And a standard temperature, that is, 1 atmospheric pressure, and the heat of melting snow L equals 2.686.78 x 10 to 19 centimeters 3. And the concept of atoms as solid spherical bodies was sufficient at that time to identify unique facts in chemistry, such as the theory of heat and the composition of matter. However, the results resulting from the study of the spectrum of light showed that the atom must have its own composition, which differs from one element to another. This is what prompted physicists to research the idea that the atom is composed of finer and smaller particles.
After this, we will talk about researching the components of matter, field, energy, radiation, regulating laws, then atomic reactions and nuclear reactors. This will be in the next videos. Do not forget to subscribe to the channel and support us to continue and provide everything that is useful to you.
Thanks for watching.